Jai Shri Gurudev. Good morning to everyone students. Welcome to chemistry class. In the previous class we learned about hybridization, under that Sp and Sp2 hybridization along with examples. Now in this class we are going to study the third type of hybridization, that is Sp3 hybridization. So in Sp3 hybridization, one s orbit and 3 p orbitals overlap together and to form a equal set of 4 Sp3 hybrid orbitals. And observe here, there is only one s orbital and 3 p orbitals. Hence, the percentage of s character is only 1 times and the percentage of p character is 3 times in 100%. It means 1:3, means s is 25% and p is 75%. Observe, the sp3 hybrid orbitals is obtained by overlapping of one s orbital and 3 p orbitals together and to form 4. 1 plus 3 4, 1 s and how many is 3 p, so p power 3. So you get 4 equal energy set of sp3 hybrid orbitals. These are called hybrid orbitals. Why we call hybrid orbitals? These are involved in hybridization. It means involved to overlap with other atoms that having single electron. Now here the s is one atom, so that its percentage of character is 25. That is, s character is 25%, and there is 3 p atoms, so that the p character is 75%. Why it is 75? Because totally there are 4 orbits, so 100 divided by 4 you get 25. Okay, so 1 s you get 25. 3 p's, so multiply into 3 you get 75. This is the s character and p character. Now here observe, 4 sp3 hybrid orbitals are there. You know sp is spherical in shape, plus how many p orbitals are there? 3 p orbitals. Those 3 are oriented in different directions, right? So like assume this is x direction p orbital and this is y direction p orbital. Y direction p orbital, and like assume this is the z direction p orbital. Okay, like assume one is px, one is py and one is pz, like that. 3 different types of orbitals are there, right? P orbitals means 3 different directions. All these 3 overlap together to get a set of 4 sp3 hybrid orbitals. Observe 4 sp3 hybrid orbitals. This is one sp3 hybrid orbit. Then this is second sp3 hybrid orbit, and this is third. This is third sp3 hybrid orbit. Now this is fourth sp3 hybrid orbit. Fourth. Like that you get 3 set of hybrid orbitals. 1, 2, 3, 4. So this is called what? 4 sp3 set of hybrid orbitals. Now observe how these 4 sp3 hybrid orbitals are overlapped with, are oriented with 4 different directions. In the order to get tetrahedral geometry. Tetra means 4, hedral. 4 corners ಇರಬೇಕು, not 4 corners, 4 planes that we call tetrahedral. Now observe, when we are drawn dotted lines here, you get like that structure. So dotted lines, these are the dotted lines. Now observe here, I can write this one. 1, 2, 3. So here one line like that, tetrahedral. So 1, 2, 3, and again there is one plane opposite to the hers. So that is called 4 planes. We call tetrahedral geometry. So the geometry of this sp3 orbitals is tetragonal geometry. tetragonal geometry, and we also called as a tetrahedral hybridization. Okay, this is the details, and now here all these four orbitals are oriented in four different directions. Hence, the bond angle is 109 degree 28 minutes. 109 degree 28 minutes. Or this can also be written as 109.5 degree. 30 minutes is equal to half a degree. So that it is only 2 minutes is left to become half a degree. So that will be nearly equal to 109.5 degree. So this is the introduction about the Sp3 hybridization. Then S character, P character, and orbitals overlapping, and you get 4 sp hybrid orbitals and geometry along with bond angle. Now we are going to study the example of Sp3 hybridization. Example for Sp3 hybridization, we are taking methane. Example, take first one, methane. And you know it is a simple alkane, its molecular formula is CH4. Okay. Now observe, here the central atom is carbon. Take carbon because only one carbon and 4 hydrogen is there. Hence the central atom is carbon. Now take carbon, its atomic number is 6. The electronic configuration is 1s2, 2s2 and 2p2. 2p2. So this is the electronic configuration, right? Now write the orbital in its orbitals. So this is the outermost shell electronic configuration. So 2s orbital. How many electrons are there? 2 electrons. Write the opposite spin. Now 2p orbitals. How many orbitals are there in p shell? 3. 3p orbitals are there. So that is one is px, py and pz. So totally you can write 2p. How many electrons? 2 electrons. 1 and 2. Okay. That is 2p2. This is electronic configuration in ground state. Now observe how many hydrogens are there here? 4 hydrogens. But only 2 single electrons are there. It should need again 2 electrons to make bond with 4 hydrogens. Okay. So that it gains energy in its ground state and jumps to the excited state. During that time, one of the electron present in 2s is jumps to the vacant 2p orbital because both have same energy, that is 2s to 2p, means present in same shell also. Now, after gaining energy in the excited state, 2s containing only 1 electron and these 3p orbitals is off field because one of the electron is jumps. So here 2s 1 electron and 2p 3 electrons. Now observe how many single electrons are there? 4. How these 4 single electrons are overlapped with 4 hydrogen atoms, each having 1 electron, a single electron. Now you know the hydrogen atom is 1 atomic number and the electronic configuration is 1s1 and in its orbitals, right, only 1 electrons. This is only for 1 hydrogen. Such kind of 4 hydrogens are there. All 4 are overlapped with each electron of carbon. Now observe, you know this is spherical spherical in shape, and this is dumbbell in shape. Those 3 overlap together and you get a tetragonal arrangement, right? Already I showed in the explanation of Sp3 hybridization. Now what you get? 4 Sp3 hybrid orbitals. All these 4, 1s and 3p orbitals are overlapped. You get Sp3 hybrid orbitals. Sp3 hybrid orbitals or Sp3 hybridization. Now observe, you know how to write Sp3 hybridization. So one s orbit and 3p orbitals overlap together, you get like that. One is s. This is the orientation of orbitals. Okay, 4 sp3 hybrid orbitals, 1 s and 3p, you get totally 4 sp3 hybrid orbitals. All these 4 are oriented in different direction in the order. You get a tetragonal geometry, like all 3 sp3 hybrid orbitals are like in triangle, and the fourth one is top like that. You get like that is called tetrahedron. Now here there is 4 s orbitals, those are spherical in shape. Now observe, one hydrogen atom is overlapped like that, s orbital, one hydrogen atom s orbital. Similarly, the second hydrogen atom s orbitals, and third hydrogen atom s orbital, and here also fourth hydrogen atom s orbitals. Okay, now here there is electrons 1, 2 from from hydrogen 1 electron and from carbon 1 electron. Similarly here 1, 2 electrons with opposite spin, they are overlapping. Okay, so this is called what? Formation of sigma bond, head to head overlapping, right? Or s and p orbital overlapping. You get sigma bond, 1 sigma bond, 2, 3 and 4 sigma bonds. You get sp3. Here the carbon is the central atom, here carbon, and this is called hydrogen, 1 hydrogen, second hydrogen, third and 4 hydrogens. Okay, so observe, this is called sp3 hybridization orbitals, and the structure of methane is written like this is molecular orbital diagram. Now bond diagram is written here like carbon, central atom, this one having sp3 hybridization. Okay, carbon. First carbon, hydrogen, bond, hydrogen. Then second one, bond, hydrogen. Then third one, bond, hydrogen. And the fourth one, bond, hydrogen. Okay, so see here, this is dotted line representation just to understand tetrahedral geometry. See, like that. And here there is a plane that is from here. See here. From carbon to hydrogen, this one, this dotted lines. So you get tetrahedral like that, 3 hydrogens like 3 directions, and this is 4th hydrogen like that. That is called tetrahedral. Called tetrahedral geometry. Simply we are written T, tetrahedral. This is the example, methane for sp3 hybridization. Now take second one, ethane. Now second example for sp3 hybridization is ethane, and the molecular formula is C2H6. So observe here, there is 2 carbon atoms and 6 hydrogen atoms. So for each carbon, how many hydrogens will get? 3 hydrogens. Okay, how many carbons are there? 2. And how many hydrogens? 6. So that for each carbon, 3 hydrogens will get after dividing equally. Now take first carbon here also same like that, means same as like the previous example. The central atom is carbon, atomic number is 6, then electronic configuration is 1s2, 2s2 and 2p2. So outermost electronic configuration is 2s2 and 2p2. Then write its electronic configuration in orbitals. 2 electrons in 2s, and in 2p there is 3 orbitals. Here there is 2 electrons only, those 2 occupied singly in 2 orbitals. Got it? Now observe, this is electronic configuration or sharing of electrons in ground state. Now after gaining energy, it will jump one of the electron from 2s to 2p. Why? Because here there is 3 hydrogens for each carbon. You should get 3 free electrons to make bond, right? So here there is only 2 hydrogens, hence 1 electron jumps to p orbit, then becomes 3 free electrons here, and here also 1 electron free. Totally we have 4 free electrons after in excited state. So observe, in excited state, one of the electron from 2s is jumps to vacant 2p. So here there is only 1 electron in 2s, and in 2p there is 3 single electrons, 2p. So totally how many single electrons are there? 1, 2, 3, 4 single electrons. So that all these 4 orbitals are overlapped together and form 1s and 3p hybrid orbitals, that is called sp3 hybridization. Hybridization will be formed. Okay. Now Here we are written only for one carbon. Similarly, there is for second carbon, for that also same. Now, how many hydrogens are there? 6 hydrogens. They take one hydrogen. Hydrogen atomic number 1 and electronic configuration is 1s1. Then its electron configuration is orbital status, like that. This is the electron configuration in its ground state and as well as excited state. So here not varies in excited state. Now observe, this is spherical and this is dumbbell shape. P orbitals, and S is spherical. After overlapping these two, you know how to write a set of hybrid orbitals. This is one carbon, only for one carbon. This is only for one hydrogen out of 6 hydrogens. Now observe, here there is 4 sp3 hybrid orbitals, right? 1 s and 3p, 4 sp3 hybrid orbitals per one carbon, right? That is already you know. So observe, I writing like that. This is one sp3 hybrid orbitals. Then this is second sp3 hybrid orbitals. Then third sp3 hybrid orbitals and fourth sp3 hybrid orbitals. 4 hybrid orbitals is right. So this is looking bit small. Now okay. Okay, this is for only one carbon. Now write here one carbon. How many hybrid orbitals are there? 1, 2, 3, 4 sp3 hybrid orbitals for one carbon. Similarly, second carbon we have to be right. So second carbon I assume here we are writing. So that also having 4 sp3 hybrid orbitals. One is overlapping with one carbon. That means neighboring carbon. One hybrid orbitals out of 4. Then remaining 3 will be like that. I am writing like this is second one and this is the third one. Observe students here, third one and this is the fourth one. Fourth one. Like that, all 3 sp3 hybrid orbitals of second carbon will be oriented like that. Now each orbital having single electron. See, 1, 2, 3, 4 electrons are there. So 4 orbitals are occupied like that. Like that. So here from one electron from this orbit and one electron from this orbit, they are overlapping opposite direction like that, like that. So here form bond. So pp orbital sideway overlapping, not sideway, end to end overlapping. End to end overlapping of p orbitals, you get sigma bond, right? Already we know formation of type of bonds by overlapping of orbitals. So how many hydrogens are there? 6 hydrogens. It is spherical in shape. So 1, 2, 3, 4, 5, 6. There is 6 p orbitals, not p orbitals. 6 sp3 hybrid orbitals. Those are overlapping by 6 hydrogens. So observe, one hydrogen is overlapped here. With the opposite spin, the second one will be overlapped here and the third one and here fifth one, then sixth one and the seventh p orbital, like that overlap. So overlapping of hybrid orbitals of p and s, that will leads or gives sigma bond. Okay, so similarly here sigma, all are sigma bonds. How many sigma bonds are there totally? 3 plus 3, 6, 1, 7 sigma bond. In previous case, 4 sigma bonds. Okay, this is the formation of ethane molecules by overlapping of orbitals. Now, this structure can be written like that. Here hydrogen, right? Hydrogen s orbitals. Now write its structure, carbon and carbon. That is carbon bond, carbon. Okay, now 3 hydrogens, right? 1, 2, 3. Similarly here, 1, 2 and 3. Okay, see here the bond angle is how much? 109 degree 0.25 minutes. 109 degree 28 minutes is the bond angle. That is bond angle is equal to 109 degree 28 minutes or 109.5 degree. So observe here also we want to know the tetrahedral geometry, right? See, I write dotted lines 1, 2, 3, 4 like that, dotted lines. So here also from this carbon, that is the 8 carbon, top carbon. So here write dotted lines from carbon to this hydrogens. Now observe, this is looking like a one tetrahedron. Now, similarly, observe for this carbon. Here there is two carbons, each carbon having sp3. This carbon having sp3, this carbon also sp3. In the last case, there is only one carbon, so that we get only one sp3, hybrid orbital of carbon. Here there is two carbons, so each carbon having sp3 hybridization. For this carbon, this is the sp3 hybridization geometry. For this one, see, I will write like vertical lines for this carbon. See? Okay. Now observe here from this carbon to hydrogen. Back of the central carbon. So you get second sp3 hybridization. So this is the one hybridization sp3. This is the one hybridization. Totally you get two sp3 hybrid orbitals or hybrid carbons. Hence the geometry is tetrahedral for each carbon. What is the geometry? Tetrahedral, that is TD. Or we are called tetrahedral geometry. Tetrahedral geometry simply is represented TD. Okay. So this is the data about sp3 hybrid.